Application 1-3, Solving Systems of Equations Using Substitution. I'm at one of the faces of Mount Yona for this video. Just thought you guys would appreciate the cool view in the background. We're going to look at some word problems involving the solving substitution that Ms. Blaylock went over with you guys. Without delaying any further, let's go ahead and jump in.
Alright, so our learning target for application 2B-3 is that I can solve systems of linear equations by substitution. Let's go ahead and jump right into some of these application problems. The first problem we're going to look at on your application is problem number 2. So go ahead and pull out your application sheet from your Algebra Embassy and we'll go ahead and take a look at problem number 2. Suppose Key Club is selling candles to raise money. We say it costs $100 to rent a booth from which to sell the candles. And if these candles cost the Key Club $1 each, and we sell them for $5 each, we want to know how many candles must be sold to equal your expenses. So we're going to have to look at two different situations here. We are going to have to look at our expenses, which is money that we are spending on the fundraiser, and we're going to have to look at our income, which is money that we are bringing in from our fundraiser. So before we start, I need to define a couple variables. Now, one of the things that I don't know is the number of candles being sold. So I'm going to let X equal the number of candles. The other thing I don't know is how much I'm having in dollars amounts for both expenses and income. So I'm going to let Y be our dollar amount. So looking at our expenses, we know our dollar amount, or Y, is going to equal what we have to spend. So we know we have to spend $100 to rent the table, and we know we also are spending $1 each on each of these candles because we have to buy them before we can sell them. Now, we don't know how many candles it was that we were selling yet, but we know that it's going to cost $1 for each of those candles that we are selling. Again, we define X as our number of candles, so we're going to leave X there. Now for income, our money amount is going to equal the amount that we are bringing in. So the only thing that we're making money from is selling the candles for $5 each. So if we're selling the candles for $5 each, that means our equation is going to be Y equals 5X. $5 times the number of candles we are being sold. Now, if we remember from our substitution, we can take what Y is equal to here, and we can replace this Y over here, since we know that Y is equal to 100 plus 1X. So I'm going to have 100 plus 1X is going to be equal to 5X. I need to solve this equation, so I would subtract 1X from both sides. So I have 100 equals 4X. I need to divide both sides by 4. So I get X equals 25. Now, remember in word problems, we always have to give context to our answers. We don't want to just leave X is equal to 25. 25 is our X value, which was the number of candles. So we have sold 25 candles. Now, let's go back to our question because sometimes we're only asked to find one value or the other. We were asked how many candles must be sold to equal our expenses. So we have actually already gone ahead and answered this answered the question that we are being posed. If we wanted to find out what our Y value is, we would plug 25 back into either one of those equations and figure out what Y was. But in this case, we were just asked to find how many candles had to be sold to equal our expenses. So we actually already have our answer. Alright. Let's go ahead and look at one more problem on this application. Let's look at problem number 4. We're going to look at two different vehicles. I'm going to go ahead and highlight our important information as we read through. Car A is going to cost $10,000 up front to buy, and it's going to cost an average of 25 cents per mile to maintain. Car B is going to cost $15,000, so it's more expensive up front, but it costs an average of only 15 cents per mile to maintain. So even though we paid more up front, we're paying less per mile to maintain. And we want to know after how many miles would the total cost for each car be the same. So again, I want to start out by defining my variables. I'm going to let x equal the number of miles that we are driving in each vehicle, and I'm going to let y represent the total cost. So I need to look at two different situations. I need to look at car A, and I need to look at car B. So for car A, our total cost is going to have to take into account the $10,000 that we are spending to buy the car, and the 25 cents per mile. Remember, we don't know how many miles, so we're going to use x, and that's going to be how we would calculate the cost for car A based on how many miles we've driven. Car B is going to be set up in a similar way. We're going to have y equals the $15,000 that it cost up front. Remember, it cost $15,000 to buy. And this time we're going to add the 15 cents per mile that it costs to maintain it. So now notice we have two equations, both set up in the form y equals. So we're going to be able to substitute. We can set these two equations equal to each other and make one new equation. We're going to have 10,000 plus 0.25x equals 15,000 plus 0.15x. Now, we need to solve for x, so we can move our x to either side of the equation, but we have to get them both on the same side. I prefer to work with positive x values, so I'm going to move the smaller value, the 0.15x, over to the side where the bigger x value, 0.25x, is. I'm going to have 10,000. And now this is 0.25x minus 0.15x, which is going to be plus 0.1x. And that's still going to be equal to the $15,000 we have left on this side. Now, we also still are working to get the x by itself. So we're going to have to subtract the 10,000 from both sides of the equation. And I'm going to have 0.1x equals 5,000. I'm running out of room, so I'm just going to recopy this up here to keep us going. 0.1x equals 5,000. So the last thing we want to do, we're multiplying by 0.1. So we want to divide both sides by 0.1 or 1/10. And we're going to find that x is equal to 50,000. Now again, recall what the x represents. X is miles. So this is 50,000 miles. At 50,000 miles, our cost is going to be the same. All right. We were asked how many miles would the total cost for each car be the same. Now, we weren't asked to figure out how much it would cost, but just in case we were, I'll go over real quick how you would figure that out. You would plug this back in to your original equation, and you could plug it into either one. But you would have y equals 15,000 plus 0.15, and we replace x with that 50,000 miles we just found. Alright, if we open up our calculators, and we'll give this just a second to pop up for us. But if we open up our calculators and calculate this out, we are going to do, oops, there it went. Alright, and we're back. Alright, we would do 0.15 times 50,000. That's going to give us 7,500. And we're going to add that to the $15,000 that was already here. And we're going to figure out that the cost is going to be $22,500. Alright, we weren't asked to find that. Again, we were just asked to find the miles. But if we were asked to find what the cost would be when they were the same, we would just plug it back into either equation and we get that dollar amount. That wraps up the video for application 2.3-B. Go ahead and finish completing that application. Thanks for watching and good luck on your mastery check. Let us know if there's anything we can do to help you out, and we'll see you in 2B-4.